Okay, this video is going to cover 5.3 in the Calc book. That's separation of variables. The assignment for this section is on page 391. Four problems out of the textbook, and then there's five more on WebAssign. So this will be our last section for Chapter 5. It'll be the end of our differential equations. And here we formally see the separation of variables we've been talking about in the last couple of videos. And it says here we're going to recognize and solve differential equations that can be solved by separating variables and use them to model and solve real-life problems. And then the book says, consider a differential equation written in this form. So we've got something here with x's in it. We've got something here with y's in it. And then there's a dy dx, and it's equal to 0. Where it says m is a continuous function of x alone, n is continuous of y alone. As we saw in the last section, for this type of equation, all x terms can be collected with the dx and all y terms with the dy. And a solution can be obtained by integration. Such equations are said to be separable, and the solution procedure is called separation of variables. Below are some examples of differential equations that are separable. So let's see, first one, nice and easy. It looks like all you'd have to do is cross multiply. Notice the y plus 1 in the denominator here. They did put that in parentheses and made it a quantity. For the next one here, you would subtract. I would subtract this term here from both sides. Over here it'd be negative. Multiply both sides by the dx. Here, change this to a dy dx. And then it looks like they divided both sides by cos. Sine over cos would be tan. Move it to the other side where it is cotan. Oh yeah, so just leave it like this. Divide by sine. Cos over sine is cotan. And then change that to a dy dx. Put the dx on the other side. And for this one, multiply both sides by that quantity. Or no, just make this a dy dx. Multiply both sides by the dx. Multiply by the reciprocal of x. So that'd be a 1 over x on the other side. And your variables have been separated. So here in example 1, it says find the general solution of this. And we've got an x squared plus 2 quantity, dy dx, and then an xy on the other side. So the first thing, we've got one term on each side, or over here it's two terms that are multiplied. So let's multiply both sides by the dx. Now the dx is on the other side. So let's get all our y's on the left, all our x's on the right. And let's see, it looks like we're just going to have to do a little dividing. Over here on this side, we're going to divide by y to get that out of there. So over here on this side, we will be dividing by y. We're also going to have to divide both sides by the quantity x squared plus 2. Or excuse me, x squared plus 4. So this is getting a little messy, but here we've got the dy left up top. We've got a y down below it. And now on the other side, we had an x there, and we're dividing by the quantity x squared plus 4. And we've got our dx. So there it looks like we've separated the variables. And the next step, of course, is going to be to antiderive each side. Now, both of these look logarithmic integration. Over here, dy over y, u prime over u. That's just going to become natural log of y. And over here, downstairs, we've got x squared plus 4, so we do need to tweak this. We're going to need a 2x upstairs, and we'll have to balance that with a half out front. So this is going to be 1/2 the natural log of our denominator, x squared plus 4. And we'll put our plus c on this side. Now, before we base e, we should get our logs to just have 1s in front of them. So over here we're ready to go. We can base e this side, but before we base e this side, let's move the half upstairs. It's going to be up here as an exponent now. And, well, yeah, maybe we'll even make that into a square root symbol again. So we got a base e this side. And remember, this is one big exponent with a plus in it. We add exponents when we multiply like bases, so we can change this into a times e to the c power. So over here on the left, e and ln cancel, so we just get y equals. Here, these are going to cancel, so we are going to have a square root of x squared plus 4. And then this e to the c turns into a constant. We'll just put that in front and make it a multiply. Y equals c times the root of x squared plus 4. In some cases, it's not feasible to write the general solution in the explicit form of y equals. The next example illustrates such a solution. Implicit differentiation can be used to verify that the solution is correct. And I almost missed part of the directions here. Given the initial condition, y of 0 is equal to 1, find the particular solution of this equation. Okay, so let's start separating our variables. And it looks like, well, I'm going to keep this term over here on the left because it's positive. So this will be subtracted from both sides. So now over here on the right side, it's a negative x, y, dx. Okay, so it looks like I got my y and my my y's and dy's on the left here, so let's keep those. Let's subtract, or let's divide this out. We're going to divide by e to the negative x squared. So over here in the denominator, e to the negative x squared. And then it looks like we got a y here we have to get rid of. So we're going to divide by y, and over here divide by y. So let's see on the left, y squared minus 1 over y dy equals, let's move this e to the negative x squared up to the numerator. So now that's e to the x negative x times e to the positive x squared dx. All right, let's start thinking, how are we going to antiderive these? Okay, on the left, if we check u prime over u, it's sort of backwards. Single term denominator, let's break it into pieces. So our first piece would be y squared over y. That's just going to turn into a y. Minus 1 over y. Let's leave it like that. dy. And on the other side, let's leave that as it is for now. So on the left, we can just antiderive each piece separately. So with respect to y to the first becomes y squared over 2. And then minus 1 over y, well, that's natural log form, the natural log of y. And that's equal to, I should have had an integral sign there. Let's see on this one, e to the u. So if this is our inner function, e to the x squared, what's the derivative of x squared? 2x. We need a 2x dx. We've got the x and the dx. We don't need the negative, so we could just pull the negative out front. But we do need a 2 here, and we'd balance that with a 1/2. So now we're ready to antiderive. Again, the rocket fuel will burn up. We'll have a negative 1/2 e to the x squared power plus our constant. Now it did say, I believe in the directions there, sometimes it's hard or impossible to get this into explicit form, y equals f of x. If we tried to solve this to get y alone, we've got an ln of y here, so we're going to have to base e both sides. Because we've got another term, y squared over 2, that's going to make that extremely difficult. And we'd have to base e this side. So to get this into explicit form would be very difficult, if not impossible. So in this case, we're not going to have to do that, but we can use the given point to find a particular solution. So remember, they did ask us to find the particular solution of this point. The input is 0, the output is 1. So 0, comma 1. So there it is. So we're going to use the point 0, comma 1. So the y value here, y squared, that'll be 1 squared, or 1 over 2, minus the natural log of our y value. We can drop the bars now. Natural log of 1. That will turn into a 0, equals negative 1/2 e to the x squared will be 0 squared. That'll also turn into a 1, plus c. So 1/2 minus natural log of 1 is 0, so that would be minus 0. We'll leave it off. Here, e to the 0 is 1. 1 times negative 1/2 is negative 1/2. And then there's our plus c. Add half to both sides. C is equal to 1. So for our particular solution, we'll just go back through, and put that c, replace that c with a 1. So we had, what was it, y squared over 2 minus natural log y equals negative 1/2 e to the x squared. And then we'll have our plus 1. Taking out the constant, replacing it with our positive 1. Now, something we can do for this, usually the book in the solutions will at least clear the fractions. Notice we have here denominator 2, denominator 2. We could multiply through by 2 and then get y squared minus 2 natural log y equals negative e to the x squared plus 2. And if you are on the AP test and these don't perfectly match some of your multiple choice answers, remember we can move this 2 up to an exponent, make it appear as a squared. So we could then drop the absolute value bars minus the ln of y squared. Yeah, we could add the this negative e to the x squared to both sides. Guess that would make it look a little better. Have a plus e to the x squared equals 2. And I guess that's good enough. Example 3. Find the equation of the curve that passes through the point 1, 3 and has a slope of y divided by x squared at any point x comma y. So here's our graph, undefined at the origin, but we're going up. There's our point 1 comma 3. So we want the particular solution there. And then here would be our curve. So has a slope of. Let's see, in calculus, slope dy dx. Our slope is defined as y over x squared. So let's see here, just a simple cross multiply is not going to do it, but if we cross multiply to get us started, we'll have x squared dy equals y dx. And we're going to divide both sides by x squared, as well as divide both sides by y. So I'll work back up here. So on the left side, dy over y is equal here. I'm going to slide this dx sort of off of there. That'll be 1 over x squared, or let's write that as x to the negative 2 dx. Variables are separated. Let's antiderive. Left side natural log form, natural log absolute of y, equals here. We will raise the power by 1, divide by the new power, -1, add on our constant. Base e, so that'll just be y equals. Now here, if I did a rewrite first, -1 over x plus c. Now we're going to base e that, so this becomes one big exponent. And remember, we add exponents when we multiply like bases. So I could turn this into a times e to the c. E to the c just turns into another constant, which we'll put here in the front. C e to the -1 over x power. So we've got our general solution, general. Now we want to find the particular. There it is. So they gave us a point, 1, 3. X turns into a 1, y turns into a 3. So our exponent here becomes a -1 over 1, or just -1. Let's divide both sides by e to the -1. Or we could just say c equals, bring that up and make it positive. 3 times e to the first. Okay, there we go. So we've got our general here, and now this is our particular. So our c is the same as this. I'm going to take out this c and replace it with 3e to the first. So let's see what that's going to look like. Y equals, well, I need a little more room. Shoot. Let me do this. There we go. So y equals, this c is out. I'm going to replace that with 3e to the first. And then we still have to multiply that by this e to the -1 over x.